Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. This video is going to pick right up from where heat map part 1 left off. In this video I'm going to add the ability to change the set points from the nextion and apply them to the Arduino. And then the Arduino is going to update the set points on the nextion, so that way there's a little bit of feedback. I'm going to start in the nextion. As I said, I'm starting up right where I left off, so I'm not going to go through what we already have. I am going to move this picture over, because I'm going to have to add a button here later for page 2. I've added a page, and now I'm going to add 5 buttons and 2 number fields. Now normally I fast forward through this part of the setup and the buttons just are there, and I don't go through this part because I figure most people know how to add buttons and such. But in this case I'm going to go ahead and show you one feature in case you didn't know about it. If you hold the control key, you can select multiple items. And then if you go down to the attributes, I'm going to expand this a little bit. You can set them all at once, and I want them all to be 75 by 75. And then if you select off, you can select back on and only select the ones you want. I'm going to select the 2 leftmost ones. In this case I want them both set equal to 10 from the left. And then I'm going to go through and I'm going to set them all that way. But I've added a separate font over here that's a little bit bigger. I'm going to change the font in N0 and N1. So that way it's a little bit bigger. I thought I had them both clicked. Hopefully it comes up a little bit better on the video when I upload it. Now I'm going to configure the buttons, the text on the buttons. So all I've done is I've labeled these buttons to be high value and low value, and we're going to increment it and decrement it. And that's how we'll send the set points back to the Arduino so that we can control the mat and change the set points easily from the nextion display. And what I have is on the release for the high plus plus, you can see I just have n0.val plus plus. And then on the high minus minus, I have n0.val minus minus, and then for the low plus I refer to this n1 instead and increment it, and for this one I decrement it. And I usually do things on the release, and for the page I just have it set to go back to page 1. So it's pretty simple code at this point. It's not really going to do anything other than change the numbers here. But now we have to go back to page 1 and add that other button. And even though this one's page 0, I'm going to make it appear that this is page 1 and the other one is page 2. So I have the code set to page 1 and I have it set to page 2. So visually it'll look a little bit nicer. Now the other thing, when we're in the Arduino and we're sending values up to the nextion display, I want to be able to access the X0 and the P0 fields even if I'm not on the appropriate page. So I'm going to set those to global. If you're worried about memory, you can do it in another way by using some system variables, but in this case we're not really concerned with that. And you can see when it's set to global that these are black and this one over here is yellow. That's an indication that it's set to global. And then we'll go back to page 1. I'm going to do the same thing with these because we'll want the Arduino to be able to update the number fields even when we're not on the page. Now I'm going to run this in debug just to make sure that I have everything set right. See, I have this set up and page 2 takes me to page 1. I can increment and decrement. But before I close this, we have a problem because see, this low level can be higher than the high value, and we don't ever want that to happen. So we're going to put in some checking for that next. And we'll do it on the buttons themselves. So when I increment this value, we won't really have any problem. It can always increment. It's when we decrement the high value that we could have an issue if it goes below the low value. So we'll click on that and look at the code. And what we've done is we've added some lines that if n0 is less than or equal to n1, we want to make it turn it into something equal to n1 plus 1. That way, if n0 ever falls below n1, it will just automatically revert to one number above n1. And the same thing with n1. We want it to always stay below n0. So when we're decrementing it, we should be okay. It's only when we're incrementing it. So the only thing we have to worry about is this low plus plus. So now if n1 is ever greater than or equal to n0, we're going to make it equal to n0 minus 1. So it should always stay below. Let's make sure that this works. So now we're starting even. So if I go negative, it should go to 1. And it does, even though I decremented it. And when I go positive, it'll stay at 0. But if I go up to 4 or 5, it should stop at 4. And it does. And I shouldn't be able to go below 4. So now we have to send the values to the Arduino. And we're going to do that. We have to send it as a string format, and we'll have to concatenate or combine multiple strings. Well, the nextion doesn't really do that very well. So what we have to do is we have to create two variables, and we'll load a value into the variables, and then we'll add the variables together and then send those. The first one I'm going to call temp, and we're going to make it a string. And then the second one, we're going to name it send string, because it's going to be the string that we're sending. And I'm also going to make it a string. So now we have to go back to our code, and every time we tap that button, we need to send something. The first thing we'll do is we'll take that value of n0 and we're going to convert it to a text, and we're going to store it in that temp.txt field. If we hit the low B2 or B3 buttons, we would be working with n1 instead of n0, but the logic will still be the same. And then we must create the string that we're going to send. And I'm going to start with that C:C, and that's just a delimiter to let me know in the Arduino that I've received a string that I've sent. So if I see that C:C, then I know that it's a legitimate string. And the next thing will be the command. In this case, we're going to send HIL. And then that's going to be concatenated with the temperature itself, because we took that and converted it and stored it in the temp register. And then in the end, we're going to add that question mark to it. And that will just let me know, it's another delimiter at the end to let me know that the string is done. So that way when I get this, collect the string in the Arduino, I know I have a complete command, and then I can use the string or manipulate it any way I want. And then in the end, we're going to send that string. For high minus minus, we're going to do the exact same thing, because we're sending that n0 value again. Didn't matter whether we push plus or minus, because we're sending just whatever value is in there. Now for the low side, the only change that I made is the variable after the C:C, the command. And whenever I set up the nextion, I always try and keep all my commands the same length. And in this case, I'm using 3 characters. And that way in the Arduino, I know I'm looking for a 3-character command. There's other ways to do it, but it's simpler for this video, especially if you're only sending a few commands. Okay, now at this point, we have the nextion all set up. We've got the commands copied. I'm going to compile it one more time and run it in debug just to make sure we're sending the commands correctly. So now when I push the numbers, we should get a line down here. Let's set this to string, because we'll be sending strings. And you can see it's the high level, and it's 2. If I go down, it'll be 1 again. We ended on 7. Now if I hit the low button, it's LOL and 1. So now we just look for that C:C. We know we got a command. If it's followed by a question mark, we know we have the complete command. And then we can look at the 4th, 5th, and 6th characters to determine what the command is and then get the value. Now at this point, I'm going to upload this to the nextion and to the display, the actual display, and we'll switch over to the Arduino. Now for this video I'm adding the EEPROM library because the Nano has some built-in double EEPROM, and we're going to store the high temp and the low temp, so that way if the power goes out or anything, it will be in there. And you do that just by adding the EEPROM.h library, and then I'm adding two variables, a high temp and a low temp. Then in the setup, the only change we have to make is we're going to read from the double EEPROM memory and store the values in high temp and low temp. And so we're going to have this just in the first two locations. We will read location 0, and then for the low temp we'll read location 1. And then at some point we'll have to dump the current values into there, and then they'll be stored the next time we boot. And then this delay runs every 5 seconds. I believe that's where I had it set at. So we're going to add one line in here, and we're just going to print those values out just so we can make sure that we're reading them properly. Now we haven't assigned or we haven't written anything to the EEPROM. At this point we're just going to read from it. So I'm not 100% sure what values we get, but I'm going to upload this and run this in the serial monitor just to see. So we're currently reading 255. The temperature where I'm working at is 62.04. What we're going to do is we're just going to set 1. I'm going to take one value and I'm going to force it to be 75. And the way you write to the double EEPROM is double EEPROM.write, and then you put the memory location, in this case 0, and 75. And we have to put that prior to our read, because if we wrote it after our read, we'd still be reading that 255. I'm going to run this again, but you also have to understand that we can't leave this in there. We're going to have to pull this line out because we want to write the actual values while the Arduino is running, but if we left that in there, every time we would start it up, we would rewrite that 75. And you can see we've changed the value now. Now it's 75. So now we'll go back and we're going to delete that line that we added and continue on. And right here we have if temp greater than 75 and if temp less than 71. We want to change that to use the variables that we've created. So now we have high temp and low temp. Let me double check and make sure I did call it low temp. Sometimes I use LO instead of LOW, but I did, LOW. And then we're going to do the same thing we did. We're going to digitally write out the relay to turn it off or on, and then change that picture. So at the end of the asynchronous delay, or every 5 seconds, we're just going to take whatever the Arduino says the high temp and the low temp are, and we're going to force that into page 1 N0 and page 1 N1. So even if we're on the nextion display and we're making a change, and the change didn't make it to the Arduino and alter the Arduino will override it. It should only happen every 5 seconds, so you should be able to make the changes and never really notice. But this will just force the nextion to display what the Arduino is showing. And notice that I added page 1.n0.val, and that's because of the global variable set for N0 and N1 on the nextion. I'm going to upload this to the Arduino now, and then I'll switch over to I'll bring up the camera view of the nextion display, and we'll see if it's kind of working at this point. You can see we have temperatures. It's going to act funny because our low temp set to 255. But let's make sure it's showing that on the display. And it's not, so I must have the wires backwards. And there we go. Now we have it back. So now if I make a change, remember if I try to go up, it should correct and go to 74. And it does. Oh, but the nextion is saying, yes, make that change and go to 74, but since we're not recognizing it or reading the values into the Arduino yet, it's saying, nope, the Arduino still says it's 255, so it's going to be 255. So it's really working like we thought it would, which is good. But we can also see that the error correction on the nextion is also working. And if I go minus up here, it should go to 256, and it does. So now we'll go back and add the code so that we can read the values from the nextion in the Arduino. And we do that up here in this serial2.available area. The first thing we'll do is we're going to make it so that we can read or display the DFD. So as we collect data, it will show up on that serial monitor. And at this point, it should be collecting the data because we're sending it. So I'm going to go ahead and upload this. And then here's our display. And we're outputting. It's going to be a little confusing. I've turned the auto scroll off. It looks like we're getting some garbage. But if I hit a button on the display, I'll scroll down now. You can see that we got that C:C LOL 25. So we're getting the data, but we're getting some garbage, and we're also still, for testing, sending out that other information. So what I think I'm going to do, go back up here, I'm going to comment this out so we're not getting this stuff, this high temp, low temp, and this temperature. And that way we can just see the garbage and what the nextion is sending to us. So now you can still see that we're getting some garbage, and that could be because we're sending it information that is not, like we're sending that pick information up to it, and I'm on the wrong page on the display. I've cleared the output, and you can see that we're getting these, and I'm on this page, but at the same time the Arduino is trying to change the picture. So I'm going to change the page back to, go back to this main page here. And then I'm going to reset the Arduino. Well, actually, I shouldn't have to reset it. We should just stop getting the errors. Okay, and you can see that it stopped. We're not getting anything back. And that's because we're just sending P0 and X0 instead of page 0, X0. And when we're on page 1, or page 2, the one where we can make the changes, and we send that float number or that P0 selection, and we're not telling it what page, the nextion says, that looks like a command I don't understand, and it sends an error message back. I really should be getting error on the display here because I have that error checking portion in here. I'm not sure why I'm not getting that, but that's a question for another day. So now we'll go back in the code and we'll add that other, we'll add the page 0 to the commands that need it. And that's right in here. So we add page 0 to this one. We have to do it up here. And wherever the X is, which is right here. Let's send this up and make sure that we've gotten that issue cleared up. As you can see, we're not getting anything. I'm going to go to the other page. And now if I go up though, we should get some commands. And there we've got the command, and that would be to set the low level. Of course, the Arduino doesn't know how to handle that command yet. That's our next step. And we take care of that up here in where we collect the data. I'm commenting out that serial.println command just because I don't want to fill it up with a bunch of data like that. So what we're going to do here is we're going to check, and if the DFD length is greater than 3 and the first 3 characters are equal to C:C or are not equal to C:C, that means we've got some sort of garbage and we're just going to erase the DFD at that point. But if the first 3 characters are C:C, then we're going to move into that else. And then we're looking for the last character. And if the last character is a question mark based upon the substring there, we're just going to print good string. That means we've got it, we know it was a good string, and we're going to print that we're going to reset the DFD back to basics or back to nothing. So I have it uploaded, and I should be able to press a button and get a good string, and we do. So now we know we're sending good strings. Now we just have to manipulate the string and then write the values back up to the nextion display. So we'll comment out this so we don't get that good string being printed. So the first step we'll do is we're just going to pull the data we want. We're going to get the command, which is going to be the second set of 3 characters, or 4, 5, and 6. And so then we have to get the value, and that can be a variable length because it could be 5, 10, or 100. So it can be 1, 2, or 3 decimal places. So we have to do a little bit of logic to figure that out. And then we're going to print the command and the value just so we have something to display, because at this point we're not writing anything out to the display. But if the command is HIL, then it's the high temp. So we're going to write to the EEPROM that value, and we're going to set the high temp to that value. And then in the asynchronous delay, we're going to use that to tell whether to turn the mat on and off, and we're going to send the value back up to the nextion. And if the command is LOL, we're going to write to the location 1, which is the low value, and we're going to send that value, or use that value in the async delay, and send that value back up to the nextion. So we're taking the nextion and we're writing it to the Arduino, and then we're going to take that value and send it back up to the nextion. So you get a little bit of feedback that way. In part 3, I'm going to also add a little light to each page to let you know if you've lost communication to the Arduino. Okay, so now we're up and ready to go, and we're not getting anything on the display because it's not doing anything. I mean, it is doing something in the background, but it's just looking at those static temperatures. So if I hit that low plus plus, that's going to try to make 255 go to 256. But since the low has to be below high plus plus, it should read out and change it to 74. That's what I'm hoping. And it did. And we got our LOL of 74. And so then we've got our temperature. Our high temperature is 75 and our low temperature of 74. But let's go back to page 1. And our temperature right now in the basement is 62 degrees. So I want to make some adjustments so that I can make the heater come on and off. Right now the heater is supposed to be on. Oh, that's plus. I'm going to go down. So we would want the heater to turn on if it falls below 62. Let's make it 64. Oh, that's the wrong button. But let's make it turn off if it gets to like 68. So now if I warm the heater up, it should change states at 68. And it did. So now we're able to control the set points on the nextion display and get a little bit of feedback from the Arduino to make sure they're actually talking. It's going to take a little while to set it down, so what we can do is we can go here and I can increase my high level, and then I can increase the low level, and I'll do it quietly and we'll see if we can hear the relay click. There, so the relay clicks, so when I go back it should be, the heater should be on, I believe. On, yeah. So when it's red, it's heating, and it's trying to get the heat up to 60, whatever I left it off at 70 degrees. If I warm it up again and get it to 70, it should kick off. And there we are. So I'm going to review real quick. So we added this EEPROM library so we can store it. It doesn't really affect this particular one today, but if I were to hit reset on the Arduino, it would hold that temperature. And then in the setup, we need to read those temperatures in from the EEPROM and store them in high and low temp. And now we have this serial to available section where we're collecting the data, we're interpreting the data, and then we're doing something based upon what we see. But we have both a string at the beginning, the C:(C), and the question mark at the end is delimiter, so we know we're getting a good string. And now down here in the bottom, our big thing was to change things to global and to decide that we wanted the Arduino to go ahead and overwrite the values on the nextion. If you were to leave these lines out, it would function just fine. You just have to trust that the value in the nextion and the value in the Arduino, that there was a connection between the two, because the nextion would send the values to the Arduino, but with no feedback coming back, which I guess you're kind of getting those picture and the temperature itself, but with no feedback from the set points, you don't really know that you're setting it. And then on the nextion, what we did was we added a second page, and we made it so that we can send the values with those key features. And we did that with 2 separate strings, so we can build the string up in a way that's easily readable. You could combine like the C:(C) and the LOL into one string, but I like to break it up so that if I go back and look, I can see that that was my delimiter, and then that's the command, and then the value, and then the question mark. And then we just sent that out. And then we did change a couple things to global. N0 and N1 are global, and on page 0 we set X0 and P0 to global, so that no matter what page we're on, we're going to be able to write to it. Because otherwise, if you were to change pages and it was only writing every 5 seconds, there'd be a little bit of a delay. Otherwise, it's kind of nice that it just writes directly to it. In my next video, I'm going to add a small light, a little indicator in one of the corners, probably in the lower right, that will be red if it's not talking to the Arduino anymore. It'll be green as long as communications are fine. And I'm going to add that second temperature sensor, so I can have a temperature that shows me the ambient in the location, and it can show me the temperature of the current temperature of the heat mat itself. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.